We're going to use the area beneath our curve that's modeling the inches of rain per hour to find the total accumulation of rain in this particular rainstorm. So from 2 a.m. to 4:30 a.m. the rain came and went, sometimes with some severity, and the curve that patterns the inches of rain per hour is given by -7/180 times x minus 8 squared plus 2 plus the sine wave 0.6 sine of 8 pi x over 5. The fundamental theorem of calculus tells us that the area between a curve and the x-axis can be found by finding the antiderivative of your curve and evaluating it at your endpoints. So our endpoints are lower limit of 2 for 2 a.m., upper limit of 4.5 for 4:30 a.m. The first term in our curve is a power function of 2. The antiderivative will then be a cube. I added 1 to the power, and then you divide by the new power. So this is the antiderivative of that term. The next term in the curve is 2. The antiderivative of 2 is 2x. And then the third term is our sine wave. The antiderivative of sine is negative cosine. The 0.6 gets carried along as the coefficient multiple. Inside of the sine wave was the input of 8 pi x over 5, so that remains the input on the cosine. But then I need to multiply by the reciprocal of this coefficient so that this is the antiderivative of that function. So again, sine's antiderivative is negative cosine, and then you also need to multiply by the reciprocal of the coefficient inside of the wave function. Now that we found the antiderivative of the whole entire curve, we're going to plug in the upper limit and the lower limit. The upper limit is 4.5, so I replace x with the number 4.5, and then if we carefully type this in the calculator, you should get 9.65235, and the units are inches. Plug in the lower limit of 2, so all the x values become a 2, and carefully type that in the calculator. You get 6.89657 inches. The overall accumulation then from 2 a.m. to 4:30 is the difference between the upper limit in the antiderivative and the lower limit in the antiderivative. So that difference is 2.756 inches. Again, we arrive at total inches of rain because we were multiplying the units of y, which was the rate inches per hour, by the unit of x, which was hours, and the hours cancel out, leaving us inches. Now it kept raining at 4:30, but there's a different function that patterns how the rain tapered off from 4:30 to 8 a.m. So we'll find the area under that curve, and then we'll add the two together, and then we'll know the total amount of rain in that storm. Alright, so our rainstorm continued from 4:30 a.m. and it tapered off at about 8 a.m. But there's a new pattern to use to model how the rain was accumulating in inches per hour. So that new function is 2.736 over x minus 3 squared. So we want the total inches of rain. Again, the units of this function are inches per hour. So when we multiply the units of y by the units of x, we will have our total accumulation in inches. The area under the curve by the fundamental theorem of calculus is the antiderivative evaluated between our limits. Our lower limit is now 4.5. Our upper limit is now 8. 4:30 is where this pattern started, and then the storm stopped at 8 a.m. Note that an x minus 3 squared in the denominator is equivalent to a power of -2. That's how you want to view this function, because to find the antiderivative you're going to use the power rule because you have a power function, a power of -2. So the antiderivative of a power function is you add 1 to the exponent, so negative 2 plus 1 gives us a new power of negative 1, and then you divide by that new power. So that gives us an antiderivative of negative 2.736 x minus 3 to the minus 1 power. I now plug in my limits, so that's why we've plugged 8 in. When you plug the upper limit of 8 in, you get negative 0.5472. Then I'm going to also plug in my lower limit of 4.5. When I do so, I get negative 1.824. I know it seems funny for these values to be negative because we are talking about an accumulation of inches of rain. But remember, the overall area is the upper limit value minus the lower limit value. So when you find their difference, you get positive 1.2768 inches. So it accumulated an additional 1.2768 inches between 4:30 and 8 a.m. So the entire storm from 2 a.m. to 8 a.m. accumulated 2.756 inches, and then our additional 1.2768 inches for a total of 4.033 inches of rain. Quite a lot of rain for one storm.